Okay guys, so welcome to another lecture of system design. Now in this lecture, I'll be talking about some of the common terminology that we generally heard about when we are talking about a system design or when we are building it. Now just a disclaimer for everyone that these are not the only component which exist. Apart from that, there are tons of other component which also exist inside a system design, and eventually I'm going to talk about that because I have already mentioned those component inside your syllabus. But yeah, so for today's class, let's try to talk about these common component, by the way. So in general, whenever we talk about any kind of a system, we generally heard about a term called as throughput. Now, what is the meaning of this throughput, by the way? We say that throughput of the system is this or that, and now what is the actual meaning of this? What is the exact meaning of this one? So a number of request system can handle in a given point of a time. For example, so Eury example, obviously one of the common example that I'm taking since my very first lecture. So if Eury can process 100 chat per second, right? 100 chat messages per second, then we can say that okay, the capability of Eury or throughput of Eury is 100 requests per second. So number of requests, based on that, if we are going to judge a system, so that term is basically called as throughput. That this is a throughput of this system. If I'm trying to design maybe some sort of a website, some sort of a portal, and that particular portal can handle 100 requests per second, per millisecond, per microsecond, per minute. So we are going to say that, okay, a throughput of this system is n requests per minute, per second, per millisecond, per hour, or whatever it is, depends upon the request it is going to handle. This is the very first term. Now, the second most popular term is called as latency. Latency means a delay, basically a delay, a time which is required to get a response from a system. So here, what it means, by the way, the time it takes from a system to respond to a request. Lower is better. That's a disclaimer for this one. Lower is better, as lower as possible. So let's suppose if you are sending a message to a Eury, say hi, or maybe you are asking some sort of a question that tell me about a system design. And Eury is going to give you a response in maybe a microsecond, maybe in a millisecond, maybe in a second, or maybe in hours or minute, whatever it is, right? So if Eury is going to reply back to you in 1 second, so we say that latency of this Eury system is basically 1 second. Yeah, latency of the system is 1 second. For example, here I have mentioned that if you are sending a message and your friend Eury is going to reply in 1.2 second, then you say that okay, so latency is basically 1.2 second. Now, there is another term called as horizontal scaling. So what is the meaning of this horizontal scaling, by the way? I'll try to explain you with the example once again. So whenever we try to design a system, so obviously we try to design a system based on the load, based on the request system is going to get. Now, if system is getting more load, if system is getting more request, so what we do is, let's suppose I have this system with some configuration, with some CPU, with some RAM over here, with some memory. So what we can do is, if I'm getting more requests, which this system will not be able to handle, we can try to add one more system. We can try to add one more system. We can try to add one more system. And we will keep on adding more and more system. And obviously we are going to establish a communication or connect between all of this system. Maybe in this way, or maybe in a centralized way, right? Maybe in a centralized way. Now, this is called as horizontal scaling. So whenever there will be more load, we add a new system. We add a new server. System means server, by the way, right? So we add a more system, and that is called as basically horizontal scaling. So here I have mentioned that adding more machines or more server to handle more load. In case of Eury, so if 1,000 users are online, Eury add more server to serve all the user smoothly. And if like a 10,000 user, and from 10,000, if we are going down, so obviously it will try to keep down all the other system which it has spawned in a particular time period. Now there is something called as vertical scaling. Vertical scaling means, so here I have a machine, right? A single machine. Now, as per my requirement on day one, I have added some CPUs, I have added some RAM over here. And then when my requirement goes up, when my traffic goes up, if I'm trying to add maybe more CPUs, more RAM into the same machine, for example, I'll give you example of your laptop itself, right? So whenever your laptop gets slow, so generally you say that okay, maybe I'll try to upgrade my RAM from 8 GB to 16 GB, right? Now that is something called as vertical scaling in a very, very simple way. So hope you are able to understand a vertical scaling and a horizontal scaling. Horizontal means adding more machine. Vertical means giving more power to a same machine. Now there is a term called as replication factor. Replication means just replicating a same thing into a different places. Yeah, just replicating the same thing. So what is the meaning of this one, replication factor, in terms of a system design? So just trying to make a copies of same data across a different server for a availability, maybe in a different country, maybe into a different region, or maybe into a different places. So if we are trying to put up a data, for example, so let's suppose if I'm trying to host Yuri and for India, right, for India, and then let's suppose if I'm trying to maybe like keep Yuri alive for maybe a USA and maybe for a UK. So what I can do is I can try to take one server here, I can try to take one server here, I can try to take one server here, and then I will try to replicate those data in all of these servers. Now, what is the advantage I will be able to get? So let's suppose my Indian server is down. Yeah, this particular server is going down. So in that case, whoever is going to request anything to my Yuri, it is going to give a response from here, or it is going to give a response from here. So in that case, like what I'm trying to say is that if one server is going to fail, it is going to get a response from other server. And this is where replication comes into a picture. So all the time, whenever we are trying to design a system, we always make sure that if one server or if one region or if one entire country server is going down, it should switch back to a different server in a different region, and it should serve my user in the exact same way. Maybe your latency is going to be increased a little bit for some time, unless and until the old server is not coming back. But yeah, it will be able to answer, or it will be able to serve a request from a user. And that is possible with the help of replication factor. Now, all of these components which I'm talking about here, so in detail, in depth, I'm going to give you an example as we will move forward. You can check out your syllabus. All of these things are already mentioned, and you will be very happy about it. Now, so there is another term called as sharding. So in general, we hear about this particular sharding. So what is the meaning of sharding? Sharding is nothing but splitting your data into a small chunk, so that I will be able to query on my data with a very, very low latency. And that is possible based on the sharding, right? So here I have mentioned that splitting a large data into a smaller part and storing them separately. So maybe if you are trying to query with the Yuri, based on the user ID or based on the reason from where user is trying to hit a Yuri server, we can try to split a data. We can try to split a data so that whenever someone is going to query anything with respect to those data, it is going to go through a user ID, or it is going to go through the way I have split the data, and then it will try to answer. Yep. So here inside a Yuri, so user memory data is split based on the user ID, which ranges across a multiple databases to prevent a overload, so that it will not just go and query one single database at any point of a time. It will be splitted across a different databases. Now there is something called as a rate limit. Even we have applied this one inside a Yuri. So The meaning of rate limit is very simple, restricting how many requests user can make in a particular time period. Whatever time period that we are going to define and whatever number of requests we are going to define, that will become a rate limit. For example, so if a free user, right, we have a URI for a free user, we have a URI for a paid user. So we have applied a rate limit for a free user that if user is going to send more than 100 message per minute or more than 10 message per minute, it is going to ask an user to wait for some time, right? So this limit that we have applied on top of the request that user can make is called as a rate limit. And all the system out there which you are using even now is going to apply, or they have applied a rate limit that, okay, so I'm going to allow only this much number of requests, this many number of requests for a particular user in a particular time period. Now, there is another term called as eventually consistent, right? Eventually consistent. So in general, what we do is that we try to upgrade a system. We try to release a new feature consistently. Yeah, consistently. We try to give a new kind of a solution to our user. And this is what every company is doing out there, right? So when we are trying to release a new feature, it should not like it should choke my like a end user who is already using my system, which is live, right? Which is using my system live. So this is where this eventually consistent terms comes into a picture, where system try to update itself in a background. So user who is using it, a live user who is actually using it, they should not get any kind of a impact. And the latest release, a latest update that I have pushed, so it may take its own sweet time to replicate to my old user. Yeah, to my old user. Now there is another thing called as stateless services that we use a lot, right? That we use this term again we use a lot. So what is the meaning of it? That every request is going to be independent. Means there will be no linkage between my previous request and this request. It simply means that whenever you are trying to chat with a URI, if it is a stateless one, right? If it is a stateless one, so whenever you will try to chat with the URI, so every request, every message that you are going to send, it is going to treat those messages as a separate independent message. It will not be able to find out a relevance between the past and the current one. And this kind of a system is called as stateless services, where there will be no state, there will be no connection in between, right? So if inside a URI, we have not done that, by the way. So if inside a URI, we are going to turn off a memory module that we have designed. So in that sense, in that way, every request that you are going to send, it will not be able to recognize that it's coming from you or we had some sort of a discussion even before. It is going to treat each and everything as an independent request that URI is going to get. So this is something called as stateless services. Then again, the 10th last but not the least, like I said, so there are so many other terms which you will be able to find out. So this term is called as heartbeat and health check. So in terms of system design, we always try to configure a heartbeat or a health check for not just one system, but for a multiple system, which is dependent or which is independent on each other. What is the meaning of that? That we will keep on pinging to the server. We will keep on pinging to our services that whether this service is alive or this service is down. And we will keep on tracking those services consistently. We will not as a human. So we have configured that in such a way that it will keep on checking all the services which we have configured. And if something is going to be down, so in that case, it is going to raise an alarm. Maybe it is going to send an email notification or maybe a Slack notification, a WhatsApp notification to my team. And my team will after getting this notification, so immediately they will come and they will try to fix those services which was down. And that is possible with the help of what? With the help of a concept called as heartbeat. So simple, like we will keep on pinging those services after a particular interval. In a regular interval, we will keep on pinging those servers or the services or the application that we have up and running for my end user. So this is where this heartbeat and health check comes into a picture. So how we are handling that in a URI. So we are using a multiple models inside a URI. Again, a models from OpenAI, a Gemini model or Llama model or Mistral model or DeepSeek model. We are using some of the APIs. We have hosted some of the models. So now here, what URI will do is, so URI will always ping OpenAI backend. Just an example that Yuri will keep on pinging OpenAI backend. And let's suppose by mistake, because we don't have a control over OpenAI, right? So it will keep on pinging OpenAI, and if OpenAI will be down, but Yuri should not be down, right? Yuri is not supposed to be down. So in that case, what it will do is, so it will try to reroute the entire traffic to other models, which is up and running and alive. And that is possible with the help of mechanism called as heartbeat or consistent health check. So hope all of you are able to understand this common terminology. Whatever system that you are going to design, these common terms will come into a picture. And again, I'm going to reiterate all of these common terms when I will be teaching you a different kind of a system design architecture with respect to the respective system. So with that, guys, thank you so much. Hope all of you are enjoying this lecture, and wish you the best. Learn as much as you can and then grow in your life. With that, thank you so much, everyone. Take care. See you again.